15 seconds. Impact point is steady.
Okay, nice and easy on the turn. Stand by for designate.
In the early morning hours of January 17, 1991, the sands of Arabia reverberated with the thunderous sound of jet aircraft. One of the largest air armadas ever assembled was streaking toward targets in Iraq and Kuwait. In that first 48 hours, U.S.-led forces would fly over 1,300 sorties and launch 114 cruise missiles, striking missile sites, air defense units, communication centers, weapons industries, power plants, and other military installations crucial to Iraq's war machine. A new kind of war had begun. A war of high-tech weaponry that had given the U.S. clear superiority in the opening air battle. High-tech weaponry that had blinded and crippled Iraq's air defenses and power to retaliate. A superiority that could only come from the weapons of Desert Storm. The Patriot system is a highly capable medium-range air defense weapon designed to engage enemy aircraft and missiles. The Patriot has a range of 37.3 miles and superb acceleration, allowing it to quickly reach a maximum speed of Mach 3 and intercept its target. During battle, the missile is controlled by a manned engagement control station. This station receives information from a remote-controlled MPQ-53 radar. The multifunctional radar provides search, tracking, and identification of targets, as well as Patriot tracking, guidance, and electronic countermeasures. Once the missile is launched, the MPQ-53 directs the missile toward the target via the system's unique TVM guidance method. TVM provides the fire control computer with instantaneous information that optimizes the Patriot's trajectory and range. Just before the missile's closest approach to the target, the 91-kilogram warhead is detonated. The explosion produces a fragmentation pattern of splinters that is designed to incapacitate the primary target as well as any trailers. Along with its sophisticated radar and excellent flight performance, the Patriot system's low maintenance and mobility make it quite suitable for desert warfare. Usually deployed in a battery of 8 launchers with 4 missiles per launcher, the Patriot system can provide land bases and ground forces with a very capable and reliable air defense weapon. A defensive weapon that has been proven in combat and is now an essential part of Operation Desert Storm. While the Patriot's success had diminished the threat of Scud strikes, the initial phase of Operation Desert Storm nearly eliminated that threat entirely. With a combined arsenal of over 2,600 aircraft armed with the latest in advanced weaponry, the Allied air assault targeted every aspect of Iraq's war machine. From Scud batteries to communication centers, the Allies bombed with pinpoint accuracy and unrelenting fury. Laser-guided missiles, radar-detecting missiles, bombs guided by television pictures, map-reading missiles, all were used to incapacitate Iraq's war machine and achieve air superiority.
Guns are going off all over the place. Time hack. Nice shooting, too.
The first targets destroyed were hit by Tomahawk cruise missiles, launched from several different ships in the Persian Gulf. This was the first combat use of the Tomahawk, and the results were spectacular. Manufactured by General Dynamics and McDonnell Douglas, the Tomahawk's success can be attributed to the weapon's autonomous guidance system called TERCOM, or Terrain Contour Matching. With this technology, the Tomahawk follows a topographical map photographed by reconnaissance satellites. This information is stored in the missile's electronic brain, allowing it to follow the contours of the ground en route to its target. The low-flying Tomahawk is then able to penetrate enemy radar undetected and accurately strike its target without warning. Traveling at an altitude of no more than 100 feet, the Tomahawk has a range of about 600 miles and carries a 1,000-pound conventional warhead. In Operation Desert Storm, its unique capabilities allowed American forces to use the Tomahawk for high-precision strikes against heavily defended targets. During the first hours of Operation Desert Storm, Tomahawk missiles spearheaded the Allied air attack on targets in Iraq and Kuwait. Minutes later, an onslaught of fighter and bomber aircraft slipped through enemy air defenses to hit their targets with unprecedented accuracy. Manufactured by Grumman, the EA-6B is a carrier-based aircraft designed for tactical electronic warfare. A crew of 4 operates advanced electronic surveillance and high-powered jamming equipment. The Prowler's objective is to suppress and confuse air defense radar so attack fighters and bombers can complete their missions. 5 external pods located under the Prowler's wings and fuselage house the electronic jamming transmitters. Radar jamming can be varied through the frequency spectrum by changing the combination of frequency transmission from each pod. This flexibility makes the EA-6B an effective weapon against a wide range of radar. The Air Force's EF-111 Raven complements the EA-6B's capabilities by providing U.S. aircraft with a faster and long-range ECM aircraft. The Raven's 3 tons of sophisticated electronics blankets enemy early warning radar with electrical noise, filling their screens with a haze of false targets. The Raven carries up to 32,000 pounds of fuel, keeping it aloft for over 4 hours. This allows the aircraft to fly holding patterns miles away from enemy fire, while using its transmitters to jam enemy radar. In addition to its long-range advantages, the aircraft can reach a maximum speed of Mach 2. These speed and long-range capabilities allow the Raven to escort bomber groups, providing frontline electronic countermeasures against enemy air defense radar. But Operation Desert Storm called for detection and destruction of heavily deployed enemy air defenses. To achieve this radar hunting, F-4G Wild Weasels, flying in company with attack aircraft, were used to destroy Iraqi surface-to-air missiles. The F-4Gs were equipped with high-speed anti-radiation missiles, or HARM, which home in on the SAM's radar transmitter. With the radar antenna destroyed, attack aircraft could then complete their mission in comparative safety.
HARM has several operational modes. Direct attack options include a semi-automatic quick reaction mode to suppress radars threatening the aircraft, a crew-selectable target of opportunity offensive mode to attack unsuspecting radars, and a long-range standoff mode allowing attack of known radar sites from a safe distance. Regardless of the operational mode used, HARM has the ability to adaptively retarget in flight should the operational situation change after the missile has been fired. This capability, called Flex Logic, is unique to HARM and allows the missile to complete its suppression mission in a battle situation. The guidance section contains a broadband radar frequency receiver, which features high sensitivity and the ability to discriminate between the signals in a modern radar threat environment. Guidance operation is controlled by a digital central processor unit, which executes target identification, tracking, ELINT, and autopilot functions. The control section features a strapped-down inertial navigation system, providing onboard position data to the CPU for computation of optimum missile flight trajectory. The propulsion section is a low-smoke solid propellant rocket motor with a boost and sustain phase to achieve high speed and long range.
The success of Operation Desert Storm's initial bombing runs relied heavily on the electronic countermeasures and radar hunting capabilities of America's high-tech aircraft. With these defenses diminished, a barrage of attack aircraft saturated the night sky over Iraq and Kuwait. The initial air attacks were led by Lockheed's stealth F-117As. This sleek, futuristic-looking fighter utilizes its shape to dissipate radar signals. It does this by reflecting the signals in numerous directions, away from the searching radar. Consistent with stealth technology, the F-117A appears to have no radar. However, the military confirms that a sophisticated navigational system is in place. The single-seat F-117A is equipped to carry a full range of U.S. Air Force tactical fighter ordnance, including one 2,000-pound anti-radiation or air-to-surface missile, For precision placement of these bombs, the aircraft has a forward-looking infrared sensor that the pilot may augment with infrared goggles. The F-117A's stealth technology gives it enhanced defense suppression capabilities, as was the case in the initial stages of Operation Desert Storm. Unfortunately, we are unable to show you many of the F-117A's advantages and capabilities because of the classified stealth technology. Accompanying the F-117 on the Allies' first bombing runs were F-15C and F-15E Eagles. Manufactured by McDonnell Douglas, the F-15 Eagle is the Air Force's air superiority fighter. Reaching speeds 2.5 times the speed of sound, the F-15 Eagle has numerous capabilities depending on the type of fire control, radar, and weapon systems that are used. If configured with 2 McDonnell low-drag conformal fuel tanks, or CFTs, the Eagle can accommodate avionics such as reconnaissance sensors, radar detection and jamming equipment, laser designator, and a low-light TV system. The F-15 can also be equipped for long-range bombing by adding a special weapon attachment to the CFTs. Known as tangential carriage, this modification allows for an expanded ordnance of 12 1,000-pound class bombs or 4 2,000-pound class bombs. As an air-to-air combat aircraft, the F-15 has exceptional capabilities. Along with superb maneuverability, it can carry 8 air-to-air missiles, 4 AIM-9LM Sidewinders, and 4 AIM-7FM Sparrows. Enhancing the F-15's air combat as well as its air-to-ground capabilities is the Hughes APG-70 radar. This advanced radar system gives the pilot detection and tracking power up to 170 miles ahead. The system is used to locate targets well beyond visual range or in close formation, regardless of weather conditions. For tactical target missions at night, the F-15 is also equipped with wide-field forward-looking infrared systems. This imaging system amplifies starlight thousands of times and allows pilots to identify targets cloaked in darkness. This system, along with similar night vision devices, played a crucial role in the opening success of Operation Desert Storm. The F-15, working in tandem with its advanced weaponry and detection system, is an awesome force. One such example during Operation Desert Storm was the work of F-15E Eagles and TV-guided GBU-15 glide bombs. This 2,000-pound bomb carries a TV camera in its nose that transmits pictures back to the aircraft. Using these pictures as a reference, the pilot can control the path of the bomb and guide it directly to the target. This type of advanced weapon is ideal for attacking heavily defended targets.
The GBU-15 system, developed by Rockwell International, gives the United States Air Force a standoff strike capability against a variety of defended targets. GBU-15 increases the aircraft's chances of survival by allowing it to operate outside enemy defenses that protect high-value targets. The weapon is launched from standoff range, and the aircraft can immediately leave the launch area. The weapon has a television seeker in the nose. The picture from the seeker is transmitted by RF data link to the cockpit of the launch aircraft. The weapon system operator uses the television picture to locate the target area. When the operator identifies the target, he can lock on the weapon's automatic tracker. As the weapon reaches the top of its climb and begins a descent to the target area, the operator can improve the aim point if he desires and continue on automatic track. He also has the option to manually guide the weapon to impact. The GBU-15 was designed to be effective against such targets as bridges, airfields, industrial sites, caves or aircraft shelters, air defense sites, and ships.
Within 2 days, Allied air superiority was so definite, B-52s began pounding the elite armored and mechanized divisions of the Iraqi Republican Guard. The B-52s employed a devastating bombing technique called carpet bombing. This type of bombing utilizes the massive B-52's ability to carry enormous payloads of bombs. Flying in a formation of 3, the B-52s can drop 150 750-pound bombs in an area about as big as 9 football fields. Carpet bombing's immense destructive power lays waste to the ground below and softens enemy ground forces in preparation for ground attacks. With B-52s flying high overhead and attack fighters saturating the skies below, the coordination and tracking of 2,600 aircraft was of utmost importance. The crucial role of orchestrating everything from bombing runs to mid-air refueling was left up to the Air Force's E-3 AWACS. The AWACS advanced surveillance systems have the ability to identify aircraft as friend or foe through an electronic encoded signal. If an enemy aircraft is spotted, the crew of 20 go to work transmitting information to U.S. aircraft. In some aircraft, such as the Navy F-14, the AWAC can transmit information through a direct data link to the pilot's cockpit computer. Information obtained on any ground activity by spy satellites and radio eavesdropping planes can also be transmitted to attack aircraft via the AWAC. This type of advanced communication has been crucial in locating and destroying mobile Scud missile launchers and targeting Iraqi ground forces. During the early bombing runs over Iraq and Kuwait, the laborious chore of air traffic control was another duty handled by the E-3 AWACS. Its radar system can keep track of as many as 2,000 aircraft at once, displaying their locations, altitudes, speeds, and headings on a variety of computer displays. In an operation the scope and size of Desert Storm, this mundane chore proved to be one of the most vital. The Allied air campaign against Iraq's command and control structure, the nuclear and chemical facilities, its military-industrial complex, and air defenses was only the first of many phases in Operation Desert Storm. The second phase included strikes on bridges, highways, and other transport routes. This isolated Iraqi ground forces in Kuwait and prevented any resupply or reinforcement operations. With enemy ground forces cut off, Phase 3 called for increased air and naval bombardment to soften enemy forces. The final phase of Operation Desert Storm, G-Day, combined massive air and ground forces in a 3-prong assault into Kuwait and southern Iraq. The swift success of the ground offensive was remarkable. American and Allied troops punched through enemy defenses and quickly outmaneuvered Iraqi forces. Just as they had done in the air war, the Allies utilized the latest in high-tech weaponry to gain the upper hand in the desert. Since World War II, the workhorse of desert warfare has been the tank. Its mobility and firepower in unpredictable terrain and under extreme weather conditions has kept the tank at the forefront of weapons technology. The challenges of Operation Desert Storm called for a quick, mobile, and powerful tank, a tank that could counter the Soviet T-72. The Army deployed the Abrams M1A1 as their main battle wagon.
A new measure of quality in armor has emerged. A weapon system fusing high performance and reliability, advanced technology and precision craftsmanship. A main battle tank with incomparable crew protection, quickness and agility, firepower. the M1A1. Today's world-class performer. Exceptional design embodied in the M1 series of battle tanks has shattered traditional concepts of armor. The M1A1 has combined high mobility, maximum crew protection, and precise firepower into an advanced weapon system that is second to none. From the manufacturing plant to the field, the M1A1s are tanks which have demonstrated continued high performance in a variety of conditions. Tanks which are easily operated, easily maintained, a tank you can depend on. On the battlefield, a weapon system must be depended on to perform whenever called on. The survival of the soldier and completion of his objective are at stake. In service to the United States Army, the M1A1 has continually lived up to its world-class reputation. The M1A1's performance has gained the trust and confidence of the men who operate this remarkable machine. High mobility is a quality very few main battle tanks can claim. The M1A1 main battle tank delivers without compromise. Astounding quickness and acceleration permit use of evasive tactics on the battlefield. The vehicle's high speed on or off-road allows it to be positioned rapidly and strategically. A powerful 1,500 horsepower turbine engine provides the vehicle with remarkable speed and quickness. An advanced suspension system enables the M1A1 to maneuver with exceptional agility. The lethality of a fully stabilized 120mm main gun in the M1A1 is coupled with digital fire control and thermal imaging. The system can fire on the move at high speed in all weather conditions, day or night, with tremendous accuracy. Technologically advanced armor, as well as compartmentation of the fuel and ammunition, provide structural safeguards for the four-man M1A1 crew. Onboard systems, like the nuclear biological chemical unit and a fast-acting fire suppression system, have been repeatedly tested to conform to rigid design criteria. The M1 series was designed from the ground up to provide protection to the crew and systems in battle. Low vehicle silhouette and internal smoke generation make the vehicle difficult to detect in combat. These features, combined with unequaled armor protection, quickness and agility, and lethal firepower, all add up to a unique vehicle with unparalleled crew protection. The M1A1, an advanced technology weapons system capable of rugged, continued performance, ready today to meet the challenges of tomorrow. The M1A1, a world-class performer.
While the M1A1 was the spearhead for Allied ground advances, air support played a key role in taking out their opposition, over 5,000 enemy tanks. The Apache AH-64A is an advanced attack helicopter capable of undertaking a day, night, or adverse weather anti-armor mission. Its firepower and mobility allow it to fight, survive, and live with troops in a frontline environment. Extremely quick and mobile, the Apache has a vertical climb rate of 2,460 feet a minute and can travel at speeds up to 192 miles per hour. While engaging other aircraft, its mobility is exceptional, making quick turns and changes close to the ground. The pilot rides in an elevated rear seat just aft of the co-pilot gunner located in the nose. During ground attacks, the Apache's Target Acquisition and Designation Sight System, or TADS, tracks and locks onto the target. Target information is relayed to a heads-up display, which is built into the pilot's and gunner's helmets. The primary mission of the Apache AH-64A is to destroy heavy armor by using its battery of Hellfire missiles and 30mm automatic cannon. The Apache can carry up to 16 tank-killing Hellfire missiles. Traveling at 800 miles per hour, the Hellfire missile can hit targets up to 5 miles away with its 14-pound warhead.
Rockwell International's Hellfire is the United States Army's newest and most effective operational anti-armor weapon system. Hellfire is laser-guided. There are no wires controlling the missile. This allows the helicopter to launch the missile and leave immediately to avoid enemy fire. A ground laser designator team in a hidden location places a laser spot on the target's most vulnerable area. The spot is invisible, but this special camera allows it to be seen for this demonstration. The Hellfire missile locks onto the laser spot and follows it to impact. The laser spot can come from the launch helicopter, another helicopter, or from another aircraft. Since the helicopter is not tied to the missile by wire and the missile flies at supersonic speed, exposure time is greatly reduced, which means greater safety for the helicopter and crew. Hellfire can also be launched at night and in adverse weather for better concealment from the enemy. Hellfire can be operated in the direct fire mode where there is line of sight to the target and the missile is locked onto the target before launch. Or the helicopter can take advantage of concealment and launch in the indirect fire mode. The missile acquires the laser spot after launch and locks onto it while in flight. With Hellfire's accuracy and shape-charge anti-armor warhead, Hellfire defeats all known armor. Sequential or salvo-type launches are possible with Hellfire in combination with one or more designators. These engagement modes are extremely effective for target-rich environments. Hellfire has been launched from the ground. Being able to fire the missile in the indirect mode allows the launch crew to take advantage of natural terrain masking for protection.
TOW, the versatile, mobile, heavy assault anti-armor infantry weapon system. Designed, developed, and built by Hughes Aircraft for the United States Army and Marine Corps. Combat tested, TOW has proved to be highly accurate and devastatingly effective. The combat record of TOW has been impressive. In this combat footage, taken through the gunner's sight, the effectiveness of the airborne system is illustrated. TOW is simple to operate. After the missile is loaded, the operator acquires the target, launches the missile, and keeps his sight trained on the target. An infrared sensor in the sight sees the infrared source on the missile and supplies the position of the missile to the guidance set. The guidance set processes the data and generates the steering commands, which are sent to the missile over the trailing wires. The operator needs only to keep his crosshairs centered on the target until impact. As the armor threats become more difficult to defeat, the U.S. Army will continue to improve the effectiveness of the TOW weapon system.
The advanced technology that has become such a large part of the American military has made a lasting impact on the way wars are fought. Computerized bombing, digital communication, and electronic countermeasures are now the keys to success. These weapons have ushered in a new era of warfare, a high-tech battlefield of precision-guided bombs and highly accurate missiles, a battlefield molded and shaped by the weapons of Desert Storm.
sir. 6 speed. Speed is 470.